I've been working on activity signaling, which is a way to communicate between activities when something is done or when something needs to happen. An example use case is the signaling of a completion of a child activity so that a container activity like sequence knows when to schedule its next child or when it as a whole is finished so that it can explicitly mark its own or signal its own completion. So that's one use case. Another use case is, for example, the break activity in combination with for each and while. You can imagine that if you have a for loop and you have some condition within this for loop where you want to break out of the for loop, you can use the break activity in Elsa 2. In Elsa 3, we need the same, but it's going to be implemented using signaling. In Elsa 2, it's more hard-coded, and there's pieces of code external to the activities that set or manipulate state of a parent activity, for example. It's a little bit hard to follow, and it's more rigid implementation. It requires core changes if we want to introduce a new kind of construct or some communication between activities. But with this activity signaling, we can implement pretty advanced interactions, basically, without having to change the core. At least that's the idea. We'll see how far I get, but that's what I'm currently working on, specifically for break and these for activities and for each and while, and sequence, so that the sequence knows when it's done working on its child activities. And I have a unit test actually, just to show you what it looks like. So for example, here we have a break activity. It's a very simple one. All it does is send a signal called the break signal, which is nothing more than a vocal with not even a field, so this represents a signal. It could carry some more data if applicable, but that's not the case here. And the nice thing about this is that the break activity itself doesn't need to know anything about for, while, for each activities. But of course, those activities, they listen basically for the break activity. So here, let's take the for activity, which models the C# for statement, and basically it iterates from a start value until an end value using a step. And if you want to break out of such a loop, you use the break activity, and this activity will then listen for it. So here it registers a handler for the break signal. So when the break signal is received, it doesn't matter how deep the hierarchy is. So you could have for example, you could have a for loop somewhere in your workflow, and then within the iterate, the body branch where you put in the code basically that you want to execute. It could be a flowchart, could be a simple activity, could be very complicated activity, doesn't matter how deep it goes. But at some point, if there's a break activity, that break signal will bubble up this hierarchy. So it's kind of similar to a DOM event in a document object model. It's inspired on that, but of course it's not exactly the same. But the nice thing is any activity in the hierarchy can listen and respond to a signal. So here the for activity will respond to it using an onBreak private handler, which isn't fully implemented yet. It just for now says stop propagation, so that if you have yet an outer for construct or a looping construct, you don't want it to break out of side of that as well. So I'm working on this little API to be able to control when to stop this propagation, this bubbling. What's yet to be done is some instruction set to allow this activity to actually cancel everything else that's been scheduled as below this or as a child branch of this activity here. I mentioned tests, so let's look at these tests here. Well, the for each workflow test will fail, but just to demonstrate what it's supposed to do. So here we have a sample workflow. It starts with a sequence which contains just one activity called a for each, and this for each will for each item that it receives in its constructor, it will execute a write line. And then the idea is that it at some point will break. Must have updated this. I thought I had so it would look like this. Let's take an if, and this would have some condition, and if that condition evaluates to true, let's say we then want to break out of it. So that's the idea. Otherwise we do a write line, let's say. And this, of course, would be based on maybe the current item. Doesn't matter. This test currently fails because the for each does not actually implement the breaking construct yet. But that's a work in progress. And I mentioned being able to container activities like sequence. The sequence activity should only complete once its children have completed. So here we have another sample workflow, again starting with a sequence, then a sequence of activities, one of them being another sequence. The expectation is that we would see write lines from start, then line 1 through 3, and then end, and this actually works. And as you can see in the output, start, 1, 2, 3, end. And without the activity signaling, it wouldn't work. What would happen is you would see start, and then maybe line 1, and then end, and then line 2 and 3. So it's a more flexible way of implementing it. Before this activity signaling, it was working as well, but using a more rigid implementation, which I can show you quickly. So here we have the activity invoker middleware, which is responsible for actually, well, this is basically the inner loop that works on the stack of activities to execute, and then at the end of that inner loop, it would try and complete its parents, and completing its parents means whenever an activity finished, let's see if it has any parents that want to know about this and send or invoke some method on it to notify that parent that the activity was finished. And that's this little, well, it's not a little function, it consists of a few lines, as you can see. And basically what this will do is for each parent activity execution context, see if it has a completion callback for its scheduled child, and if so, invoke it, cleaning up the activity execution context hierarchy or the branch, and continue all the way up. A little bit hard to follow, also hard to do some variations on some communication between child and parents, but with the activity signaling, we can do a lot of different constructs unobtrusively. So yeah, so that's in progress. For Elsa 2, I worked on a little thing called workflow compensation. And what is workflow compensation? That's what you do when your workflow faults, but the workflow has already performed some work. Maybe it created a flight reservation, charged a credit card, but something happened later on, and now you want to undo or roll back those steps. So here is an example from Windows Workflow Foundation, which describes the process of compensation and how that compares to transactions. It talks about the compensable activity in Windows Workflow Foundation, and that's what I took as an inspiration, including the example. So here they have a flight booking workflow basically. So this new activity, it has a bunch of outcomes. The body outcome represents the work that you want to do. That can be potentially be rolled back, but the rollback would be done through the compensate output, and the compensate outcome is scheduled as soon as the workflow faults or an activity faults, then this gets executed. And I think I have a small example for that. Maybe it's easy to just show that demo to see it in action. So this is almost literally the same sample workflow used in the WF documentation. So what do we have here? We have the compensable activity, which when it executes, will execute a body outcome. And here what we do is we charge the credit card, reserve a flight, and then once the body executed, then it will just continue with whatever comes next. So then we have a manager approval activity, and then we are simulating a fault. And this is another new activity that allows you to fault the workflow from within the workflow without having to throw an exception, which still works, of course. But this is another way to fault your workflow, and you can provide an error or a message with that. So whenever this executes, the workflow will enter a defaulted state. And when that happens, the compensated outcome will execute of this compensable activity. So it will cancel the flight and undo the credit card charges. So just to see this in action, let's run this program. So here we see the credit card for the flight has been charged, flight has been reserved, manager approval received, but then a fault happened, and that causes the cancellation of the flight and the cancellation of the credit card charges. And of course this also works in the designer, and I think I may have even prepared a design, but I'm not sure if I used it with the monolith or the server sample project, but let's find out. Well, I think I deleted the workflow, but that's okay. Let me just create it from scratch. It's quite easy. So here's the new compensable activity. Let's give it a name. Then here we will charge the credit card and reserve flight. And then let's say, what do we want to do when the workflow faults? We want to compensate for these actions. So then we will cancel the flight, cancel credit card charges. So when the credit card has been charged, the flight has been reserved, and the manager approved this little flight, and let's say we're gonna fault the workflow. The fault activity has no outcome because there's nothing to do once your workflow faults. If for some reason you do want to execute something, or even just have something visual to show what you wanted to do, like for example in this demo, you can of course just use the JavaScript activity and throw a new error. So this will cause a fault, and then we can pretend something. What else do we want to do here? And that is purchase the flight. Ultimately, we want to take the flight. And once the flight has been taken, then even if the workflow should fault after this, in this example, it would not make sense for the compensable activity to compensate the process, because it doesn't make sense. You are already on the plane. So at that point, what you will want to do is confirm the compensable. And that will ensure that even if the workflow faults hereafter, the compensate branch will not execute. So for that, you need to use the confirm activity and then provide the name of the compensable activity you want to confirm. Yeah, it's a great point. I wasn't sure myself either, but I trusted the documentation in about Windows workflow, and they also talked about a cancel option. So that happens whenever a fault occurs within the body. So if that's a valid use case scenario, and I assume it is because it's there in documentation, I figured maybe it is useful. But I agree. You could do everything here on the done branch and it would still execute the compensate branch, but then you would not have the ability to have a separate cancellation branch whenever anything happens in the body branch. So let's say here something faults, then you may want to execute different logic. Yeah, so the confirm points back to this compensable activity to confirm this one explicitly. Yeah, absolutely. So that would work. We could do it like that. But I would like to get a better understanding of why did the Windows Workflow Foundation team choose to do it like this, and I don't fully understand. So once I do get that, I don't want to miss anything. But if there's no valid reason for doing it this way, then yeah, and then it would seem simpler to have the body execute to the end, automatically confirm the compensable activity. But the thing with the compensable activity in Windows Workflow Foundation, it doesn't confirm this one, never, unless you explicitly do so. In this context of Elsa, which makes sense for when you look at other activities, like if, for example, and for, they have the if has a true and a false branch, and once either of those have fully executed, then the final outcome, the done outcome, is scheduled. I can imagine that you would expect something similar here. As you say, body would be whatever happens now in done. If something happens here, then the compensate branch executes, and if nothing bad happens, nothing faults, then the done happens. And then implicitly compensable would have been confirmed, which means if something faults in the done branch, it will not invoke compensate. Similar, or maybe the same thing that Frans just described. Yeah, we can think about it. I kind of like that. It seems more natural here. So let's give that some more thought. So what they describe is, if let's say something happens here. Let's say we have something happening and then it goes wrong. Where did it go? What? Okay, let me refresh. Oh yeah, this is my favorite feature, the random switching of the outcomes. And it happens when you don't expect it. And then, yeah. Okay, so here it is, the body. This faults, and then because this faults in the body branch, then the cancel will execute. And let me show you. So here, let's say it charged a credit card. Now something goes wrong. So all we need to do is cancel the credit card charge. So if that works, then if we run this workflow, it will go from compensable to body, charge the credit card, fault, and then schedule the cancel branch. So that's what happens. And it does not schedule the done outcome because it's now faulted and stuff has been cleaned up, but it's not going to continue. So as you can see well, you can't see the journal here right now. That's an open issue, by the way, but let's go to the workflow instance viewer. It's now canceled, the workflow, so it's not faulted, but canceled because of the compensable activity. And then if we look at the journal, it indeed went from this one, charging, to faulting, back to compensable, which gets a chance to now schedule the cancel outcome, which is then executed. So there's that. That's modeled after what the WF compensable activity does. But as you and Mohammed described, maybe it makes more sense to do it a little bit different here. Yeah, you would still be able to achieve most things except for this particular behavior of having a separate branch when something faults in the body branch. Yeah, exactly. So you would only have compensate, and here there's two types of compensation. One that happens after the body executed, and some rolling back opportunity when something happens within the body and not just in the done. Maybe that's more flexible than we actually need this thing to be, and maybe it's more valuable to have it a little bit simpler yet very useful. But yeah, let's give it some thought, and then we can make a change if we think that makes more sense. Yeah, but wouldn't you be able to do the same? Let's say we charge a credit card, we reserve a flight, and then let's say this still fails, but what if we again just do the compensate? So here what would happen, it would try to cancel flight which has not yet been reserved, so then this might fail actually, and here it doesn't try to cancel the flight. That's right, you can use the compensable activity more than once, of course. Yeah, so that's a good point. There's actually also a compensate activity to let you explicitly compensate a compensable activity, which is similar to a fault, but it doesn't fault the workflow, it just cancels the workflow, and after executing the compensate outcome of whatever you specify here. Yeah, so it's, at the very least, it's quite flexible. So that's a new feature for 2.7. It's right now available on MyGet. And then the next version, you should be able to enter as a user every 5 seconds between 10 and 11, and then it should generate the cron expression. That would make sense. Something similar is done for the TypeScript or the JavaScript Intellisense support with Autocomplete. What it does, it uses TypeScript definitions, which are dynamically generated server sites. For this, you would need something similar, probably. So this workflow starts with 2 triggers, one the cron, and then a signal received. But when you start a workflow with signal received, it's so here you configure it to listen for test. Then at this point, it's not correlated, but once it executes, the workflow instance should be correlated with this one. That sounds like a bug, because this should work in theory. You should be able to start a new instance from within this workflow, but using this trigger, and then that should just work. And if it doesn't, it means it's broken. So if you remove this line, then it works. Yeah, so what should happen when you trigger a workflow while also providing a correlation ID, then 2 things can happen. One would be, let's say, a new workflow instance gets created because a workflow was found that uses the specified activity type as its starting activity, so that's a trigger. So it should then instantiate that workflow, create a workflow instance, and correlate it by whatever correlation ID was specified. So that's 1. 2, if an existing workflow instance is found by that correlation ID, then that one executes. Yeah, I think if it finds an existing instance of the specified workflow definition, then it's gonna trigger that workflow instance, and it's not gonna instantiate a new one. Even though in this case it's a trigger, so we might have to change this, that it also uses as a trigger, which should happen, but clearly it doesn't. Yeah, if it's the same correlation ID for the same workflow definition, then it will use the existing one. It will not create a new one with the same correlation ID as it is. Yeah, we can talk about that, but yes, that's the design. But we can talk about why it makes sense or why it does not make sense, and also talk about other use case scenarios where it's actually desired that there's no duplicate workflow instances, because there's use case scenarios where you want unique workflows because a workflow is correlated with a unique customer, let's say, and then you may not want to have another workflow instance with this customer, which depending on your scenario might be interpreted as an issue or as a bug. Yeah, let's talk about when it makes sense, when it does not make sense, and how to control that, because you clearly have a scenario where it actually makes sense. So we need to find a way where we can do so. We should start with describing the expected behavior and then see if that's actually the case. And here, maybe it's doing something that's not expected. We need to fix that. And then we can also see if we can change those intended behaviors or enhance them. All right, great. Then thank you guys for showing up. I appreciate you. We'll see you next time.